Hi again, I'm Mr. Hawkins, Head of Science at Thomas More Catholic School in Purley. Today we're going to look at what are waves and the different types of waves. Today's success criteria is as follows. To understand the meaning of a wave in science, be able to identify the different types of waves, explain and identify and in fact label the parts of a wave, and be able to calculate wave speed and time period. For those of you who use this video as a bit of a base and then go on and do some of your own research, I suggest you look up the different parts of the electromagnetic spectrum and their respective uses. So let's get started. Now, a wave isn't, in science at least, what Barack Obama is doing here quite casually and quite coolly. Waves are in fact a transfer of energy from a store. So what that means is that the energy is moving from a stored position. For example, you'll see in your textbooks quite often that they're seen as an oscillation. Well, an oscillation is effectively a vibration from a set point. So waves have a rest position, and the energy from that rest position is the displacement of the particles. So overall, waves should be viewed as a transfer of energy between two stores in science, not like the royal wave down here between Prince Charles and Her Majesty the Queen. So let's go on and actually model these waves. Now, if you have a slinky, you can do this yourself at home. The first wave here is a longitudinal wave. And what you can see is that the particles within this wave, the individual parts of the slinky, are moving in the same direction as the wave. So our oscillations, going back to our previous slide, are moving along with the wave itself. In a transverse wave, we have a slightly different scenario. So here you can see that the oscillations are moving at right angles to the direction of the wave. So what that means is the wave is effectively moving up and down, or the particles are moving up and down, even though the energy is being transferred across here to the right. What I would like you to do now is to look up the meaning of the following terms. They're very important for waves, and if you have a good understanding of what these things mean, it becomes a lot easier. Okay, now I've taken these directly from the BBC Bite-Size website, and as you can see, I've put the link here. All of these terms you should know, and you'll be expected to know in your GCSEs. Okay, now, a second activity for you. What I'd like you to do is to try and label these waves. What I mean by that is, look for the different characteristics within the wave. For example, there's something here, there's something here. And on this one, the rest position is harder to place on, but I want you to try and work that out. What you should have got is two label drawings like this. So you can see that the wavelength in both of the waves is the distance between the two peaks. Okay? The equilibrium point is often referred to as the rest point, and that's where the wave starts. Here you can see areas of compression, which you have in your drawing, and in this longitudinal wave, you can also see the areas where it's extended, and that's known as rarefaction. The amplitude of the wave is the distance from the rest position to the crest or to the trough. Okay, there are two equations you need for waves. Okay, they are as follows. The first one is that time is equal to 1 over the frequency. Frequency is measured in hertz, and it is the number of waves per second. If you like formula triangles, I've told you before, I'm not a fan, but if you do like a formula triangle, it's up there for you. The second equation you need to know is that wave speed is equal to frequency times wavelength, or V equals F lambda. And what that equation allows you to do is to calculate the wave speed. Okay, what I'd like you to do now is have a go at calculating the following questions. I'm going to give you a slight hint here. Be careful with the units and read the questions carefully. Okay, here are your answers. What I would like to say is that there are a couple of common mistakes for young students, particularly when they're doing equations across all of physics. They tend to be as follows: a failure to convert to standard units. Now, you saw on the equation that you must have the wave speed in meters per second, the wavelength in meters, and the frequency is in hertz. So if you don't convert, you will not get the correct answer, and you'll be out by a factor of 10. Failure to rearrange the equation correctly. Now, that often comes from students being lazy. It's very, very important that you write it out each time as v equals f lambda. Substitute your numbers in and then rearrange. And a very, very common silly throwaway mark is that a failure to give units and answers. So make sure you do that. So let's review our success criteria. We now understand the meaning of a wave in science. We've been able to identify the different types of wave. We've labelled and identified the different parts of a wave, and we've been able to calculate wave speed, and we know how to calculate time period. I thank you very much for listening, and I look forward to seeing you again.